I'm really excited to join you here at the CNCF in Washington, D.C. Today, we're going to talk about mechanisms that you can use for developing with containers, rather than assuming that that's some downstream thing happening in the build or happening in production. These are tools that you'll be able to use in development. Here's the part where I tell you I am definitely going to post the slides on my site tonight. But in this talk, there are no slides. It is only live demos. This is it. So that's really excellent. We can take a look at lots of different tools and be able to see the various pieces. Now, I did copy all of the tools, and so they are here on this gist right here. I'll put that in chat as well. There you go. And if it's more difficult to get to this gist, you can definitely go to robrich.org, click on presentations at the top, and here it is, the making Kubernetes how we build things. So that'll get you straight there. Looks like this page might actually be out of, there we go, local development techniques with Kubernetes. While you're here on robrich.org, let's click on About Me, and we'll see some of the things that I've done recently. I'm a developer advocate for Cyril. If you're struggling with your data mesh, I'd love to learn from you. I'm also a Microsoft MVP, a Docker captain, and a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a Give Camp here in Washington, D.C., or wherever you're connecting from, hit me up on email or Twitter, and let's get a Give Camp in your neighborhood too. Some of the other things that I've done, SQL Source Control Basics. Mine is Chapter 8. That was a lot of fun to build. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into local development techniques with Kubernetes. Now, I'm going to show you a bunch of different ways to start differently, to run containers, visualize cluster content, and to debug inside of a container. Let's dig in. Now, I have this Docker compose, this Docker file here, and it starts this server here running in Node, and now I need to run it. So let me do a Docker build. Apparently, I need to tag it with hello node v0.1, and I need a dot for some reason. Okay, so once I figured that out, now I need to Docker run hello node. Do I need the dot? No, I don't, but I do need a -p, except for it doesn't go there. It goes over here, -p 3000 to 3000. And once I figured all that out, yeah, I just spent a whole lot of mental energy trying to figure out how to build and run my container. By comparison, Docker Compose up. Now, the cool thing about Docker Compose is if the container isn't built yet, it will build it. Here it's building that image, and it's starting the container. And now I can flip straight over to localhost 3000, and we see our website running. Perfect. Now, you may be familiar with Docker Compose file. If so, then this might be somewhat review, but this includes all of the different build and run details. Here's the dot. Here's the hello node version 0.1, the ports. Oh, I completely forgot about this environment variable that I had set. If you're familiar with Docker Compose, all of that is probably already known, but here's this network mode of bridge. Now, by default, when you start a Docker Compose file, it will spin up a new Docker network. Now, that means if you run two different Docker Compose files, those containers won't be able to talk to each other. In development, maybe that's not what you want. When I say network mode of bridge, I'm saying use the existing network. So maybe I have a Docker Compose file for my data storage, and I have a Docker Compose file for my backend, and I'm debugging the front end this time. So I'll start those other two Docker Compose files, and now they can, pardon me, they can communicate with each other because they're on the same network, this network mode of bridge. So that's great. That was a good, easy one. Next, let's take a look at how we can run differently. Now, in Docker desktop, we can definitely come in here to Kubernetes mode and enable Kubernetes. That's a great way to be able to get at a Kubernetes environment from our Docker environment. But we could spin up alternate Docker runtimes as well. Let me show you Minikube. Minikube is an open source project that allows us to be able to spin up new Docker environments inside virtual machines or otherwise. Now, once I've done a Minikube start, I have this other environment. In this case, I chose to run mine on Hyper-V. So here's my Minikube virtual machine. Now, I do happen to have other virtual machines set up for other environments. So I don't want my Linkerd demo to collide with my Istio demo. So I have those in separate clusters. Now, Minikube is is a great Docker runtime environment, but it's the batteries included internals exposed version, as opposed to Docker desktop that is kind of more the hidden things. So Docker compose down will remove our previous experiment. And now let's take a look at Minikube. Now I did do the Minikube start, and that spun up that virtual machine. And now that it's running, I can take a look, and now I could connect either to this IP address or to the Minikube name that I spun up. Now, Docker Desktop, when I'm teaching containers, a lot of people ask me, well, where are my volumes? And all I can say is, it's in there. But Docker kind of locks us out of that, and that's okay. But here with Minikube, we can SSH into that virtual machine, and we can take a look around. So now that I'm SSH'd into that box, sudo su cd var lib docker, where are the volumes? They're inside right here. And you can go wander around inside of these. Now, the cool part is it is the batteries included internals exposed version. So once I say Minikube docker env, and in this case, I will tell it I'm running in PowerShell because I'm running in PowerShell core. It's automatically able to detect other environments. Once I've set these environment variables, now I'm connected to Docker. It will automatically spin up my Kubernetes context. So now I can say Docker image list, and I'm running my inside of Kubernetes. Now, if I say Docker container list, it is the batteries included internals exposed version, and we can see that we have all of the details of all of the pods running our Kubernetes cluster. Now, in Docker Desktop, we can choose to turn these on and off with this checkbox. In Minikube, we don't have that checkbox. Instead, let me just take a look at that list, and I noticed that all of them start with k8s. So I'll just grep -v k8s, and now I have the list of containers only running my workloads, and there aren't any. Perfect. Minikube is this great environment to allow us to dig deeper into how the Docker and Kubernetes environments work. It's great for nested virtualization scenarios, and it's great if you want to have more than one environment as opposed to Docker Desktop single environment. Docker Desktop is definitely the easy button, but Minikube could be an alternate environment to look at as well. Next, let's take a look at Docker Watch. Now, I wish that Docker Watch was a thing. It's not. Instead, let's look at Scaffold. Now, Scaffold is a really elegant, free, and open source tool that allows me to, once I do a scaffold in it, it will watch all of the content in my folder and automatically build, optionally deploy this to a registry, and start this content inside of Kubernetes. So I have this scaffold YAML file, and it specifies my hello node image. Notice that there isn't a version here because Scaffold is going to automatically increment that every time. And as soon as something changes here, it's going to redeploy this Kubernetes YAML file. So it's running. That's great. Let's do a kubectl get all to get the node port. Here's our node port. So we are running Minikube. So instead of connecting on localhost this port, I'll connect on Minikube this port. And here is our new, here's our site running. So I'm going to come back over here, and I'm going to pop open my code, and let's go change some code. So instead of saying hello world, I want to say hello CNCF community days. Automatically, we can see our image is getting rebuilt. We could optionally push this to a Docker registry, and then it'll restart my content inside my cluster. Now, if I hurry, I can see it starting to take down the old version and start up the new version. So, yep, it's terminating. That's perfect. And it does take it a minute to terminate, especially when I'm screen sharing. But the moment that it finishes terminating, then we'll be able to see the new content inside of our web browser. So let's come back in here and refresh. And now we see the new content in place. Now that's great. I didn't have to remember the commands. I just changed code. I push save and it automatically refreshed. That's really cool. Scaffold is a really excellent way to be able to take a look at and rebuild containers anytime content changes. Next, let's take a look at what do we get to see next? Visualizing content. Ooh. Now, we do have a way that we can be able to visualize the content inside of a container. We have a Docker history command. So we can say Docker history, hello node v0.1, and it will show us all of the command lines that created the various content in our system. Now that's interesting. We can see the size, but what files ended up in each layer? Am I being inefficient in the way that I'm looking at this content? Let's take a look at Dive. Now, Dive is free and open source and allows us to be able to visualize the content at each layer. So we can cruise up and down through the layers and we can see the files running at that spot. Let's take a look at the content inside this Hello Node image. Now I'm going to hit Tab, close this folder, close this folder, close this folder. Let's get all these folders closed. There we go. I'm going to hit Tab again, and now we're cruising up and down the layers. So here's this initial layer that got us all of this content. Next up, we got the home layer. We added some yarn content into place. That's pretty cool. And now here's where my Docker file starts with work.dir app. Yep, we've got that folder in place. Next layer, I'm copying all of the content into this folder. Now it looks like I have some mistakes. I have my Docker compose file and my Docker file in place. Maybe I have extra libraries that I didn't need. Maybe I have my source code and my deployment folder. So it looks like I need to make some adjustments here in my Docker ignore file. Let's create a Docker ignore file and let's ignore Docker file and Docker compose.yaml. I also want to ignore node modules. I want those to be recreated as I build. And now if I had Scaffold running, it would automatically recreate this image for me. That's perfect. I'm glad that Dive could highlight for me the ways that I was using my container inefficiently. It's always kind of nice to be able to go look at the various layers and see if I really need that content in place. Next up, let's take a look at how we might look at a cluster. First, let's take a look at a cluster in Docker mode. So I'm going to open up Lazydocker. Now, Lazydocker is really interesting because Lazydocker allows us to be able to use a Docker cluster and be able to click through the various screens to be able to see things. Now, if you're inside a Windows command prompt, you can't actually click. But inside of a Windows terminal or inside PowerShell or on a Mac or Linux, then you definitely can click. If you're on Windows terminal, you can definitely use the hotkeys instead. So I'm going to click and let's take a look at the stats. Now this one is created, it's not running. So let's move up here. And here's, I love the concept of building these graphs inside of ASCII art. If ever you're wondering about the config that led to this, we can cruise up and down. Now you could definitely do a Docker container inspect and get this, but I often find that I need to scroll up and down to be able to get at the content that I want. Here, I can choose to scroll up and down to get exactly what I need. Here's the Lazydocker details, and I can also take a look at volumes or images as well. I'm going to hit Control C and pop out of there. And let's look at a UI way to do this. I'm going to say Docker Compose up. Oh, I'm still in Docker Watch. Let me get into here, Docker Compose up. And let's take a look at Portainer. Now, Portainer is a great way to be able to visualize the Docker side of things in a very UI-centric way. I went to the docs and I downloaded the Docker Compose file associated with Portainer. And now that Portainer is running, let's head off to localhost 9000 and log into Portainer. Now, one of the things Kubernetes will ship with a default dashboard, but authentication is not enabled by default. Here in Portainer, we are asked for an account. We haven't logged in yet, so let's set our password. The hardest part of this demo, remembering my password. And now we're logged into Portainer. Now we could hook this up to a cloud scenario. We could put an agent in our on-prem cluster. We could connect to another remote cluster. But in this case, we'll look at our local environment instead. Now it does tell us that we need to map the Docker socket into place. And we've done that here in the Docker Compose file. So here's my Docker Compose file, and we can see that we've mapped that Docker socket into place. Now this does mean that Portainer is able to control Docker, and so we don't want to do this lightly, but we do need this so that Portainer can be able to read the state of Docker as well. We're also mapping a second volume to be able to save that password in case we return to the system. So now that we've got Portainer in place, let's connect to our local stack and we can see the content. Now here's all the images that I've pulled. Yeah, there's a few, along with their hashes and their tags. Containers is really fun. We can see there's the Portainer container that we've got in place. Let's add a new container. Now I'm going to pull this container from my local instance. So let's look for hello node. Ooh, I love that IntelliSense there to be able to automatically pick it. Let's publish all ports, or we could very specifically look for a specific port. So we could look at publishing 3000. That looks great. We could also set volumes, environment variables, other details that we would want to set in starting our container. And once we've got this ready to go, let's deploy that container. Now, we've just been able to create a container inside of our cluster from a browser. So we definitely don't want to let this outside of our control. But now that we've got this container started, let's dig into that container. Now we can take a look at the logs. It looks like this. Oh, am I in a different? I'm in the Portainer one. Let's look at the Hello Node one. There we go. We can take a look at the logs and we see that it started up on port 3000. That's perfect. We can also take a look at the configuration details. So I like to come in here and take a look at the network settings and see what IP address this container got assigned. In this case, it looks like it's 172.17.0.4. That's pretty cool. I can see the ports, and I can see that port 3000 is mapped into place from the host. That's pretty interesting. And it's fun to be able to open and close these details. If ever you've scrolled up and down looking for the content or wanted to compare two different pieces, it's nice to be able to open up just those pieces that you need. Looking at this container some more, we could take a look at the console. Now, in this case, it's an Alpine-based image, so I'll switch from Bash to Ash, and I'm going to connect. From a browser, I am inside this container. Now, I'm running on a Windows box, but if I say dir, I'm inside this Linux container, so that doesn't work. Let's do an ls-la, and we can see, yep, there's that server. I haven't rebuilt this image since I created that .docker ignore file, but now we can take a look around. Now, if ever you got your container to not quite start right, or maybe you're in the wrong directory, this can be really handy to be able to take a look around. Now, if I say node server, I can start my server. And of course, that port is already in use because it's running as part of the real container. But I can also take a look at the processes, ps-ef, and I can see that there's my node server process that's running just fine. I'll exit out of this, and I'm back into my website. Now, once we're done with this container, we can click remove, and that will remove this container together with any volumes or other details associated with that. And now that container is gone. That was a great mechanism to be able to manage my cluster from the Docker mechanism. Let's do a similar thing of managing our container from the Kubernetes side. Now I'm going to do a Docker compose down to shut down Portainer. And next, let's take a look at K9s. K9s or K9s. K9s is a great command line way to be able to look at a Kubernetes cluster. Now, this is free and open source. Let's take a look in. And it uses kind of VI-like experiences. So I'm going to hit colon, and I'm going to switch to namespaces. And here's all the namespaces in my system. Let's take a look at the Nginx ingress. Well, here's a started container. We can dig into there, and I'll take a look at the logs. Here's the logs. Oh, there aren't any. Hit escape. I'm back at the controller. Hit escape again. I'm back at the list of pods. Escape again, and I'm back at the namespaces. And so we can dig through our various details inside of our cluster in a very console-specific mechanism. Now, if you only have SSH access to your cluster, maybe it's running on a Raspberry Pi, then K9 or K9s or Lazydocker could be a great way to be able to explore it. Now I hit I hit colon, and I'll say exit, and nope, Control C, and I'm back at my command prompt. Now that was excellent to be able to look at it from a console, but let's also do it from a UI. I'm going to say kubectl apply -f schooner. Oh, perfect. Now, Schooner is formerly K8 is an alternate dashboard that we can use instead of the Kubernetes built-in dashboard. Let's take a look at what port it got. Kubectl get all, and it looks like we ended up with port 32,000. So let's head off to localhost 32,000. And unlike the built-in dashboard, the first thing that we get is a login. That's perfect. Now I'm going to go grab the secret out of our cluster, and let's authenticate in there. And now we can take a look around inside of our cluster. I can take a look through the namespaces. Here's the namespaces that we saw before. I can take a look through the workloads. Let's take a look at each of the deployments there. That's pretty cool. One thing that I like to do here inside of Schooner is I'll take a look at the secrets. Now, here's a lot of secrets. I'm looking at all the namespaces, but if you come in here and the secrets are really old, it might be time to adjust your system. Let's filter down to just the default namespace where I started Schooner, and here's that secret that I used to authenticate. Now I'm running a local cluster, so I don't mind sharing that secret, but that's the secret that I used to log in. If you have access to the Kubernetes cluster to be able to get at that secret, then you can use Schooner to be able to visualize it. Now, that was really cool. I'm here inside my cluster. Let me also looking at volumes can be kind of fun. It's interesting when we abandon volumes. Now let's come back into profile, and I will choose to log out of Schooner. Kubectl right here. Kubectl delete -f Schooner, and we've taken down the Schooner dashboard. Next, let's take a look at debugging inside of debugging inside of a container. Now I have this debugging folder. Let's very specifically open that in a new copy of VS Code, and we'll be able to kick off the details associated with debugging here. Now, the first thing it's going to do is it's going to say, hey, I have this dev container file, dev container JSON inside this .dev container folder. Would you like me to open this in a debugging container? And once we say yes, then it'll take it a minute to start up, and then we'll back up and kind of talk through how we got here. So once VS comes open, reopen this in a container. And now it will reboot VS in this separate mode. Now, how did I get here? Well, I started off by coming into my extensions and I searched for the remote extensions. Now, there's a remote container extension, a remote WSL extension, and a remote SSH extension. So you can do the similar thing with your Raspberry Pi if only you can SSH into it. That's perfect. Now, this remote development extension will install all three, and that's the one I've installed. So I have this remote containers extension. Once I've got this remoting extension, I now have this button down here on the bottom left that allows me to start debugging remotely. Now, we could start by saying try, where is it? Oh, the try button is gone. There's a try mechanism in here, but it looks like it's not found it. Or I can add development container configuration files. Once I choose add development container configuration files, it will show me the various languages that it can support. Now, I can pick one of these and it'll automatically scaffold out for me those files that allow me to debug inside of a container. Now, once I've got those files in place, let me see if I can pull up the try button. There it is. Try a development container sample. Now, if ever you're playing with a technology, maybe you want to try out Ruby or Java, but you don't want to install all of the details, then you can just pull up one of these and it'll automatically start that development environment inside of a container. That's perfect. Now, how did it do that? Well, it splits Visual Studio Code in half. So we have one half that is supporting the UI and the other half that is supporting the compile mechanism and debug the language details. We have a port that connects the two and a volume mount that connects them as well. So here inside of our container, let's take a look at this content. Now, this is a Linux container, so uname -a. Yep, we're inside of Linux. Now, we are inside of VS Code as well. You can see we have content highlighting, matching the details that we need. Let's set a breakpoint right here, and let's start up our server debugging it inside of VS Code. Now, I'm going to hit go, and we can see that we've automatically got a debugger hooked up. It's going over that socket, and we'll hit this breakpoint right away. I'm going to push play, and why, yes, I would like to open this in a browser. Here now we're looking at that content debugging inside of our container, and we do see that it proxied not to Minikube, but to localhost. So if I started a container inside of Azure, OpenShift, I can get at that as well. Now we'll hit our breakpoint, and much like we could in any development environment, we can get at the local variables. We can see that this original request is coming into the URL /. We could also take a look at other content. We can use F10 to be able to step over, F11 to be able to step into. In this case, I'm going to push go, and then we'll get a second request for our favicon.ico. So we can take a look at the details of this request, and yep, we've got that favicon.ico. I'm going to undo this breakpoint, and we can see our page rendering. Perfect. Let's take a look inside. Let's stop debugging. Take a look inside the dev container JSON to understand how this works. Now here inside that .dev container folder is this dev container JSON file, and it specifies the details that we will need to be able to start our content inside of a container. Now we could specify an image like Node Alpine. In this case, I specified a Docker file. Now this Docker file is not the Docker file we'll use for production, but rather a Docker file specifically for debugging. I started with Node Alpine. You notice we're not copying any content. We're not setting a CMD, but I did add git and curl in case I wanted to do any source control operations. Now that I've got my image started, we'll come back into our dev container JSON, and we have this post create command. After the image spins up, let's npm install to be able to get any libraries inside my container. That ensures that I get the Linux specific versions, not the Windows versions that I might have installed on my local machine. I can set settings like additional extensions that I want to install inside my container, maybe supporting language versions, language settings, or in this case, I'm setting the editor to be extra large. We can grab forwarded ports, but VS Code is also really good at being able to derive them automatically. And because we're running on Minikube, we do need to tell it how to get at that content. So though it's running here on my local machine, I did also need to set up this port bind or this volume binding to get my content from my local machine into the VM so that then I could connect from the VM into the container. Once I'm done debugging inside of the container, I'll come in here and I'll say close remote connection. And now I'm back to regular VS Code. That separation comes back together. So we've been able to take lots of different mechanisms for debugging, debugging inside of containers, starting differently, visualizing container and cluster contents. You can grab all of the tools that we looked at here on this gist, and you can grab this gist from robrich.org. It's been really fun getting to share with you mechanisms that you can use for local development with Kubernetes. If you're watching this later, hit me up on Twitter at rob_rich. And for those who are here live in the event, what are your questions? What tools should I include next time?
Thank you so much, Rob. It's been a really exciting presentation. I sucked up a lot of energy. All right. I do have a quick question, though, before I let you go.
Yeah, definitely.
So the question that I have is actually on the debugging. You said that you can debug. Does that work with only local environment, local Docker or Minikube, or can I run a container, let's say, in a Kubernetes cluster somewhere, which has like access
anywhere where you can run a container? This debugging mechanism will work just fine. So if you have a container inside of Redshift or inside of Azure or inside your on-prem cluster, you can debug it there too.
Okay. All right. Awesome. Thank you so much. That's the extension in VS Code.
It is.
All right. Great. Thank you so much, Rob. I think let me quickly check if there are any questions. Oh, there is a question from Jason. Have you ever looked at the cloud native build packs?
Cloud native build packs? I haven't. Tweet me a link and I definitely want to dig in more there. That sounds like fun.
All right. Awesome. Thank you, Jason, for that question.